Hello, YouTube. This is J Coder back with another stream, and today we're going to be going over a coding challenge on LeetCode. It's called the letter combinations of a phone number, and we're going to be working on this challenge in Kotlin. And if you like this kind of stuff, please subscribe to the channel, like, comment, and without further ado, let's get started. So, all right. So, what I have for you guys is letter combinations of a number, and so it says, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So we have input, the digits equals 23, and the output is this, and then digits is nothing. The output is nothing. Digits is 2, and so the output is that. So yeah, it's basically showing all the possible combinations on the digits given. Constraints: the digits are less than equal to the digits length is less or greater than or equal to 0, or less than or equal to 4. So there cannot be more than 4 digits, it looks like. So digits of I is a digit in the range of 2 through 9. All right. All right, let's get started here on this. So basically, let me go ahead and um, I I already solved this, but let's go through it again. And so basically, what we need to do is we need a base case. If the input string is empty, then return an empty list. So, oh yeah, and again, this is in Kotlin. So we're getting our Kotlin practice in today. Sometimes I do these in JavaScript as well. So basically, I'm doing the case of if it is empty, then we're going to go ahead and return an empty list. And so that's easy. If there's nothing, then there's nothing else to calculate. All right. And then the next thing I need to do is define a mapping of digits to corresponding letters on the telephone buttons. So what we can do is we could use a hash table, but in Kotlin we can use the pretty much the map of lists, And so to do that, we could or map, list to a particular number. So to represent this, I can do this val 2 letters equals map of. So we have the map of there, and we have two, and this is going to be a list of A, B, and C. And this is going to be 3. And this is going to be list of. Actually, I need to have that on there. And this is going to be a list of. Gotta make sure I put the correct capitalization there. So that's D, E, D, E, and F. This is this one's gonna be to list of G, H, and I. And this one's gonna be list of J, K, and L. And this one's gonna be this one's gonna be a list of M, N, and K, or I'm sorry, not K, M, N, O, then 7 is going to be list of P, Q, R, and S. And then 8 is going to be to a list of. So these are key value pairs here. So like in Kotlin, it's map of, but in any language that has a data structure that can do key pair values, that will greatly help in this problem. So 8 is T, U, and V, and then 9 is list of W, X, Y, and Z. All right. And so we have that there. And so we have our digits, 2 letters. And then next we have to initialize an empty list to store the result. So this is going to be val result equals mutable list of string. So that's going to be a mutable list of string. And then this one's going to be back. And okay, so after that, we need to call the backtrack function to generate combinations. So that's going to be a method I'm going to implement um, called backtrack. And the backtrack function is going to be the thing responsible for generating the combinations. So that would be, so I'm going to call the backtrack function. And so with the backtrack function, it's going to take in some parameters. So this backtrack function will be a recursive function that's going to take in the combination and the next digits and the digit 2 letters and the result. And so it's going to, so that I don't need to pass it anything right there for the start. All right. And then after that, once we have called the backtrack function, it should set the result to what we need it to be. And then so once it's set the result inside the backtrack function, we should simply be able to return the result. And so that's the extent of what we needed to do first. But now let us implement the backtrack function to generate the letter combinations for us. So outside this method, we are going to make function backtrack. And function backtrack will take in a combination, which is going to be a string, and then it's going to take the next, next, the next digits, and that's also going to be a string. And then it's going to take in the digits to letters. And this is going to be a map. This is going to be a map of char list char okay. Then okay, so this is gonna be a char, and the other one is gonna be a list of string. And then result is gonna be mutable list. And inside this mutable list, we're going to have have a string inside the result, and then inside our implementation of this function. So, all right. So basically, base case, if there's no digits to process, add the so okay. If there's no digits to process, then we can add the current combination to the result. And again, this is going to be a recursive function. So basically, we start out with if. So if next digits is empty, then we're going to add the combination to the result, and then else. All right, and then so we have that, and then basically what we need to do is do the other case, which is, so first of all, we need to get the current digit and then get the corresponding list of letters from the current digit, and then iterate through each letter and make a recursive call. All right, so what that's going to look like is this. So we're going to have val current digit equals next digits. That's going to be of sub 0. And then the next one is going to be val letters equals digit to two letters. And then it's going to be current digit is so we're gonna have to have like a conditional here, and so it's either going to equal the digits to letters current sub current digit, or it's going to be a empty list. Basically, the operator to check if it is null, empty list. All right. So we have, oh, okay. What did I just do? Okay. All right. All right. And then after that, what we need to do is, let me see here. Okay. After that, what we need to do is, actually, I don't need this guy there. And then I need to iterate through each letter using a for loop. For letter in letters, and then I need to make the recursive call, then call backtrack again, or actually call backtrack for the here, and then we're gonna pass in the combination plus. It's gonna be the combination, and then it's gonna be plus the letter plus the next digit plus, or I'm sorry, the next digit, and it's going to be substring 1, and then gonna have, this one's gonna be digit 2 letters, digit, two letters, and then the results. All right. So basically, we're going to have this uh, letters and letters, and then we're going to call our our function backtrack. It's going to have the combination plus letter, then the next digit and the substring of one, sub one, and digit two letters and the results. Okay, so we have that. Probably don't need that guy. And then so it returns. Okay. And then after it returns, it should be good. So that is the implementation of Backtrack. And let me just make sure things are correct here. Okay, so we have Backtrack. And then we should have the results. Okay. And now let's check this to see if things are good. Okay, I had some syntax issues, a syntax issue there, which we need to fix that, and then fix that guy, and then so that should be good now with those guys. All right, now let us test it. All right, so getting error down here, which is a resolve reference next digit. It's next digits actually. So I'm gonna go ahead and copy this. So basically, what we need to do is it's actually known as next digits. So gotta fix that guy right there. And then, all right, let's do I have it changed in the right places? Next digits. Okay, and now let's try it. Okay, so I have a error there. I resolved reference sub string. So I have something going on with the actual syntax. I had to backtrack. And then I have the combination plus letter. Then I have the next digits plus substring. And oh yeah, so substring, it doesn't have the actual capital camel case there. Should have just that. And then digits, letters, and then results. Okay. And then let us try that one. All right. And so that was the correct answer. And great. So that solves that problem. And I'm going to give you guys a look at the code we have here. And so we have the function, letter combinations, and then which is the built-in function that we have to implement. So basically, if there's nothing, return an empty list. Then we make our corresponding mappings to the letters. And remember, one does not actually correspond to anything. And like, if you will see, actually, we have, well, let me see. Yeah, down here, notice one does not correspond to anything else or any letters. Two corresponds to A, B, C. Three corresponds to D, E, F, and so on. And that's going to be our mappings. And then we're going to have to make an empty map to store our mappings in our our results. And so then we implement a special method, a special function to process our combinations. And then we make a recursive function backtrack, which recursively goes through uh, each one and processes the combination and until there's none left to process recursively, taking in the combination, next digits, digits to letters, and the result. And then after it's done with that, it will recursively return the result. So, yeah. And if you like this kind of thing, subscribe to the channel. That's what I have for you guys today, this coding challenge here. And as always, like I always like to tell you guys, stay coding. And until next time, peace.